So we've looked at two different implementations of the idea of a hash table, one using internal hashing, one using external hashing. Just to think about client applications briefly before we wrap up this chapter, how would we use those? Well, of course, the two hash table implementations we've looked at have exactly the same interface. They've both implemented iDictionary as the list dictionary class. And so that means we would have exactly the same uses. Any client application that needs to store keys and values associated with those keys could use any of these three ADTs in this chapter. The two hash tables will generally perform far more efficiently than the list dictionary because they're built around arrays using hashing as opposed to the list dictionary that used a linked list and has all the normal performance problems that arise with long linked lists. So we can use the hash tables for similar applications, such as the indexing example that we looked at earlier on in this chapter, and get more efficient results. But there's one key problem with a hash table, and that's that the hashing process stores the keys at what look to us like random places. They're not random. The hash value will always give us exactly the same value for a given table and for a given key. But to our eyes, the keys look like they're in no particular order, and that can be a problem, and would be a problem specifically for the indexing example, because we would like to have our index of words in alphabetic order, which the list dictionary took care of automatically for us. In the case of using a hash table, once we'd built up the index, we would then need to sort the results back into order so that we had a usable index. But the extra efficiency means for larger documents, the bit of overhead to resort the keys at the end probably still give us an overall more efficient result, at least if we're dealing with large documents. So, to wrap up this chapter then, there's a summary of the three ADTs we've looked at and their advantages and disadvantages. Which one a client program would want to use in specific circumstances would really depend on the trade-offs between the advantages and disadvantages we see here. The list dictionary is ordered, has flexible size, it can grow as big as we need it to, but we do have the disadvantage of slow access. It's based on a linked list. The two hash tables both have fast access, but both of them are unordered as a disadvantage. The internal hash table has fixed size as a disadvantage. It can only contain as many keys as the array has space for. The external hash table, however, the buckets can grow indefinitely with the simple implementation we've used for buckets at least, and so we've got a flexible size there again. And so there's a complex set of trade-offs one would need to weigh up when considering which one of these ADTs is the best for a particular client situation. Okay, well, that's the end of chapter 7, dictionaries and hash tables, and our three dictionary type ADTs that have also explored the implementation techniques for hash tables.